Welcome back, everybody. Here we are, 2.5 of the AP Environmental Science curriculum. Natural disruptions to ecosystems. What is actually going to be talked about here is how are ecosystems naturally disturbed. Now, there is a huge topic that we're going to talk about with human disturbances to ecosystems and human threats to it. But right now, we are looking at just the natural impacts of different things on the ecosystems. Now, what does the College Board think you should be able to do? Explain. Explain. So we're looking at that in-depth knowledge. So this is a really important PowerPoint, and this is a really important lesson for you to understand how natural disruptions, both short and long-term, impact an ecosystem. So we're looking at not only short-term impacts, but long-term impacts, and how do they influence an ecosystem over that long stretch. So what is a natural disruption? So a natural disruption is going to be caused by some weather phenomenon. It's going to be caused by a geological force. It could be caused by biological actions. All right, these are things you're probably familiar with. They're not caused by humans, however. So make sure you understand the difference between a man-made disruption and a natural disruption. Some examples we can talk about, like a fire, floods, earthquakes, tsunamis, landslides, invasive species, all of those things. Now, invasive species can kind of almost fall into the man-made section because it has to usually be introduced somehow, but every now and then there are vagrant organisms that kind of just work their way to different environments naturally. So they are truly still considered what we consider to be an invasive or introduced species, but they're not necessarily always transmitted by humans. Now, one of the factors, or one of the little tidbits they want you to know in this lesson is cycling of materials, or cycling terminology. And there are three major terms we use to reference cycling of different things and their frequency on the planet. So you have periodic cycling. Periodic cycling is when things are going to follow a regular interval. So we know, like, for example, the temperature in this area, that's a periodic cycling. We know it's always going to be warm during our summers and it's going to get cold during our winters. Episodic, which is going to be loosely connected events. So we know that certain things like ice ages can be episodic, even though they are kind of random in their distribution, but we know they kind of cycle back and forth. So there's a lot of different characteristics to some of these events and phenomenon to when they happen. And then random. Random, we can't predict. We don't know when it's going to happen. Earthquakes, for example, are random events. Volcanic eruptions are random events. Now, the Earth's history has changed over time. I know. I've mentioned it many, many lessons. The idea of climate change, we are going to talk about it. But the idea that the Earth's climate over time has changed, and that is a big thing to understand. Not only has the Earth's climate changed, but it's been getting warmer and it gets colder. It cycles back and forth. It's kind of more of an episodic cycling, again, not fully randomized, but it does kind of cycle back and forth. Now, why does it cycle? Why do we experience ice ages and then interglacial periods? Why do we experience areas that have gotten warmer over time and not? And it's mainly due to a lot of different factors going on. Things like the Earth's orbit and the tilt of the Earth. That's how we get our seasons. That's how different parts of the world experience different climatic conditions annually. We know that there's different levels of incoming solar radiation to different latitudes on the planet. So that's another factor that's going to influence how these things happen. And then the last thing is continental drift theory. We're going to talk about continental drift theory a lot more in Unit 4, but the idea that plate tectonics have been moving on the Earth, and as they've been moving around, different areas have experienced different ecosystems over time. So how does the sea level change in response to climate change? And this really is tying everything together with the idea of ice ages. When an ice age occurs, okay, when an ice age occurs, there's going to be an accumulation of frozen water on land. That means that the sea levels are actually going to drop. Why are they going to drop? It's because there's a volume of water on the planet. We talked about the water cycle. The volume of water on the planet is pretty consistent. Yes, you can make an argument that meteors are coming into the planet, but they're not changing the volume of water drastically. So the volume of water on the planet is a pretty stagnant amount. And now, when it starts to freeze on top of land, it's going to be pulling somewhere in order for us to have an abundance of water frozen on land. And when we talk about ice ages, like our area was almost buried under a mile thick of ice during the last ice age 22,000 years ago. So our area has experienced ice ages. Now, if you go just a little bit further north up to the Allentown area, you will get much more evidence of ice ages. Our area was like right on the cusp of true glaciation. We were probably under more of what's considered a snow field as opposed to a true glacier pushing down. Now, those periods when we have that accumulation of frozen water on land, it's going to drop the sea level. That is truly what's called a glacial period or an ice age. Then the warming periods in between that, which we are currently experiencing a warming period, that is an interglacial period. So just the differences in terminology there. It's a warming period or an interglacial period between ice ages. That's really how we look at the Earth's climate over time, is between ice ages. How many, like we use time intervals of ice ages to determine things. So here's a look at sea level rise and glacial periods. So during the glacial period or ice age, there's going to be an abundance of frozen ice, which we talked about, and then it's going to drop in the oceans. Here on the chart over here, we can see thousands of years ago, back to about 22,000 years when we had our last ice age, and we can see what the sea level was like. So different areas were, underwater or above water, depending on where they're at. So you can kind of see all these little areas up here are these kind of famous areas like Jamaica and whatnot. Was, really only became an island 8,000 years ago due to the melting of the water coming in. But some of the ice shell or the continental shelves were almost exposed as land back at the peak of the ice age. How does the Earth's environment change due to environmental change? How does habitats change to environmental changes? Well, different things are going to happen. When we talk about environmental conditions changing, the ecosystems are going to react to it. We talked about the ice ages adapting, or different organisms best being adapted, and that's what's really led to mammals thriving on the planet. Mammals didn't really evolve until about 10, 15 million years ago, and it's with the current ice ages. Yes, we're not really able to survive too well, but we have insulating fur, we have fat reserves, we can go into hibernative states to survive the winters, and it's actually like we are best adapted as mammals to survive. Now, humans are not best adapted. Like humans really exist in a true area of the tropics. We can't really exist too well outside the tropics without modifying our environment. So what we've done is we've obviously done climate control, buildings, and different things like that. Now, one of the other things is that we can talk about major changes when we talk about major climatic changes, but there are still very small changes that take place. Small changes that take place and how ecosystems recover. So here's taking a look at one example. We're going to go into forest fires a lot more. What I'd like you to do is you can watch this little video down here. That little video is going to actually go over just a quick, really, really short time-lapse video all about this area and how it's rebounding from a forest fire. The thing that happens is there are fire-prone ecosystems. They're meant to burn, and these things happen. We, as a society, don't really understand. A lot of people in the societies don't understand that a lot of ecosystems are meant to burn. When they burn, they release those nutrients. So it's really important to understand. Volcanic eruptions, we know they can be catastrophic. If you think about it, a volcano erupts, it's going to spew magma down. Magma is just liquefied rock because it's so hot. Eventually, then it's going to cool down and harden, and then you just have a fresh rock surface. And it's going to take thousands of years before life starts to colonize those areas. What about floods? How do floods destroy, or how do ecosystems deal with it? Well, there are organisms which are meant to be flooded. and some areas. Like you think about even some different habitats and ecosystems, like the Nile River is meant to annually flood. And that's when we talk about the fertile soil associated with it, because every time it floods, it deposits a lot of nutrients into the soil and it can actually help to grow different things. But we know in certain areas we can experience some catastrophic floods. Now, these are natural disturbances. Can they be amplified by humans? Yes, they can. All right, humans can suppress wildfire. Humans aren't really going to do anything to volcanoes. It's not like you can throw something in a volcano and cause it to erupt. Imagine throwing like one of those little special pellets in to throw change of fire color, and all of a sudden you have a volcano erupting blue. All right, off my little tangent. But flooding, fires, droughts, those are all associated with climate change and especially linked to human influences on climate change. So it's something that we need to be aware of, that yes, these are natural disturbances, but humans can amplify these processes. So I want you to understand that humans can amplify and can contribute to causing worse droughts, more forest fires, worse floods, because we've kind of channelized some streams and different things like that. There's a lot of stuff that humans have done that really aren't the best. How does the wildlife respond to these natural disruptions? Well, some organisms are adapted and thrive, and some organisms even alter their whole life cycle based on these natural disruptions. For example, in Africa, there's the Okavango Delta. It's in Central Africa, and what it is it's a an area that floods every time the Mount Kilimanjaro experiences its rainy season. The rains eventually rain, then they flow down these streams all the way to the Okavango Delta, where it floods. Now, a lot of organisms will go through massive migrations to get to the Okavango Delta, just because it's so productive during that short time span. Remember when we talk about productivity of an ecosystem? Well, this is an influence on an ecosystem that causes their productivity to be very, very condensed. So when organisms are going to bring their young to, because now there's abundance of food, but with it all being young there now, the predators are going to go there because now there's an abundance of food. So all of these things kind of factor together. Sometimes it leads to long-term disruptions. So sometimes you have these periodic cyclings, which is based on seasonality, but sometimes you're going to get long-term disruptions, like wildfires can lead to long-term disruptions before the ecosystem rebounds. You could talk about flooding or mass wasting events. Mass wasting referring to large movements of earth, like a landslide or a mudslide. Those can sometimes they permanently destroy an ecosystem, or sometimes it takes the ecosystem years and many, many seasons to rebound back to what it was before. So expanding on the Okavango Delta, I'd like you to pause this video and check out these awesome videos. Now, if you're really interested in it and you really like just kind of learning about nature documentary, I found this very cool wildebeest migration documentary. It talks about why the wildebeest will go through the longest terrestrial migration of any organism on the planet. They will walk thousands of miles as a herd. And this just shows you how the Okavango Delta will flood due to the water coming down, and how productive and how all these organisms kind of move to that area at the same time. So I encourage you to watch these videos. If you want to pause it right now, do that, and we're going to move on. Ostrid flies. Ostrid flies are incredible. They're small, biting flies. Obviously, nobody wants to deal with them. Think about if you go to the beach, if you get the wind coming the other direction, you get the biting flies, the blackheads and the greenheads, different things like that. They're not enjoyable. Well, these flies get so bad, they actually cause a massive herd of organisms to migrate their habitat because the biting flies are so bad. And that's the caribou. All right, caribou, they live up in the let's see here. Yeah, I'll do it. So they breed up in this area, up along the bay where there's plenty of food, and then they will actually migrate away when the flies get really bad during the summer. So they actually move up into the hills or in the valleys where the winds are stronger, it's a little bit cooler temperatures, and the flies can't survive there. So think about how bad it must be to have to migrate because flies are biting so bad. I can't imagine living in that type of situation. Here's another interesting response to environmental cycles. The red knot. The red knot is a shorebird, and why am I focusing on one specific bird? One, I know a lot about birds, so birds are actually one of the key factors for a lot of ecological concepts. And two, I had to do one of my undergrad theses on some of my environmental science lectures was based on the red knot, so I'm actually pretty familiar with this bird. Now, what it does is it spends its breeding time up here in the Arctic, in the tundra. Remember I talked about biomes, the tundra having that short window where it's really productive? Well, that's when this bird is up there. And this bird will breed, and then what it's going to do is it's going to migrate south, and it goes from the tundra all the way down to Tierra del Fuego, the very southern tip of South America. It's like a 9,000 mile flight, almost 18,000 mile round trip flight. So it's going to fly all the way down. And then in the spring, what it does is it times its migration based on lunar cycling and based on the annual occurrence. And what it's going to do is it will migrate and stops over once in Brazil. So it feeds there. And then it will fly all the way from Brazil to here, to Delaware Bay, and especially like Cape May, somewhere along the Delaware Bay shoreline of New Jersey. Why are they coming in there? Well, they're coming in there sometime between the last 2 weeks of April and the first 2 weeks of May, because that is when horseshoe crabs are actually spawning. So horseshoe crabs go through their reproductive cycle and they breed and they lay their eggs right here. The red knot comes up, they land right there, and they actually eat and feed off of the eggs of the horseshoe crabs, bulk up on all that fat, and allows them to finish their flight up to the tundra, probably getting up to the tundra about the end of May, early June, when it's starting to hit its primary productivity, its maximum productivity, so that they can lay their eggs. They have plenty of food, lots of insects to eat, lots of other things to consume, and then their eggs hatch, plenty of food for them. They eventually grow very rapidly to being fully grown adults, and they migrate all the way south. Very, very interesting cycling. Here's another look at a different type of migration, and this is some of our whale species. Whales actually will migrate. Why do they migrate? Again, it's due to their resources they need. Food, safety, different things like that. So there's certain areas where there's the breeding grounds, all right, where the organisms are going to go. They're going to meet their mates. They have plenty of food available. Then they go to the calving grounds where they will have their offspring. And then those organisms will be able to survive safety from predators and so on and so forth. But some of these organisms experience massive migrations. It's all due to disturbances. Those disturbances, again, that could be natural. They could be cyclical. They could be periodic. All those different things all factor together. Now, if you understand the different types of frequency of events that can occur, and the natural disruptions to ecosystems, these naturally occurring disruptions. And then how does it impact short-term migration? Maybe you just move to another habitat because that one's been destroyed from something, or maybe it'll bounce back. Or how do you talk about a long-term migration? How do you, like, over the course of your year or over the course of your time period, how are you cycling or migrating? If you understand those things, good. You are set. If you don't really understand it, try to read over some of the standards that the College Board is asking. Send me an email, and we're going to get you through this. But hopefully you enjoyed this lesson. Only a couple more left in this unit, and we are moving our way right through the year. No problems at all. I'll talk to you guys at the next lesson. Thank you.
You like that lesson? I know you did. So why don't you go ahead and smash that like button right now. Go ahead and comment. Tell all your friends about how great that lesson was. And make sure you subscribe, because I'm going to keep bringing you AP environmental content that you're going to want to watch. Or do whatever else those other YouTube channels tell you to do. And with that, Maloney.